Greetings, my fellow viewers. Google recently introduced Gemini Robotics and Gemini Robotics Embodied Reasoning. In this video, I'll illustrate what various robots, including the Apptronic Humanoid, can now achieve as a result of these advancements. But first, let's discuss Gemini Robotics. Gemini Robotics constitutes Google's most advanced vision language action model. It leverages Gemini 2.0 as its intelligent hub. Let's examine its functionality. The initial capability, generality. Gemini Robotics utilizes Gemini's comprehension of the world to generalize across fresh scenarios that are entirely novel, resolving a wide range of tasks. The robot figures everything out just by listening to the human tell it what it needs to do. Gemini Robotics can also adapt to different objects, instructions, and environments. In reality, it often doubles the output on comprehensive generalization benchmarks compared to other sophisticated vision language action model. Notice the Apptronic Humanoid demonstrating what it can do, such as playing tic-tac-toe. Its vision language action model guides the decision on which move to execute next. In another instance, the woman tells the robot to arrange the tiles to spell out a word associated with a deck of cards. In real time, the robot computes its trajectories to align the tiles in order to spell out ace. In another circumstance, the person instructs it to prepare lunch. Gemini Robotics will use its vision language action model to determine which items are food and how to pack them in the bag. Gemini can decide what sort of force control to use when grabbing each item. Next, we will examine interactivity. For effective real-world operation, robots must possess the ability to interpret their environment and dynamically decide what actions to take. Since Gemini Robotics is predicated on Gemini 2.0, it determines these scenarios intelligently. To illustrate, it can use Gemini's sophisticated language to grasp commands, such as, "Can you put the erasers away?" Or, "Can you pass me the tissue?" Gemini Robotics has a broader scope of comprehension than other models. And when given instructions it doesn't like, such as putting a banana on top of a refrigerator, it will adapt to the new instruction and put it in the sink instead. The robot can detect environmental adjustments and changes to direction from a human. And dexterity is also a key feature. Gemini Robotics attains a level of dexterity that exceeds previous expectations, enabling robots to perform complicated multi-step tasks that require considerable force control. For example, folding origami or storing items in a Ziploc bag, all across multiple embodiments, which suggests Gemini Robotics authorizes a multitude of robots to execute the tasks at hand. Last, we examine Gemini's enhanced understanding. In conjunction with Gemini Robotics, Google has introduced an emblazoned reasoning update. Embodied reasoning enhances the robot's understanding of its environment. Enhanced spatial awareness allows Gemini Robotics to merge Gemini 2.0's existing capabilities. Gemini Robotics can implement entirely fresh capabilities in real time. Additionally, because Google DeepMind values safety, they have designed Gemini Robotics with a strong emphasis on safety. What actions does it see as safe to execute in real time, and how will it adapt its responses? Gemini Robotics adheres to specific robotic safety standards. This is a means of ensuring advanced models comply with human ethical standards. The Asimov dataset also enhances the framework, offering a standardized test to evaluate the safety implications of each robot decision across various environments. So what are your thoughts on these robot skills? Feel free to comment below, like the video, and consider subscribing.